The sand cone method is one of the most common methods that are used for FDT or field density tests in highway construction. The dry density test is carried out in the field to check the compaction of the layers. The two main objectives of this experiment is to determine the density of compacted soils and to figure out the in-place density of natural soil deposits, aggregates, soil mixtures, or other similar materials. ASTM D1556-00 or the standard test method for density and unit weight of soil in place by the sand cone method is a major instrument in determining the densities of soil and sand. The objectives of this experiment is to determine the density of compacted soils and to determine the in-place density of natural soil deposits, aggregates, soil mixtures, or other similar materials.
Scope. This test method was used to determine the in-place density and unit weight of soils using a sand cone apparatus. This test method is applicable for soils without appreciable amounts of rock or porous materials in excess of 11/2 inches or 38 millimeters in diameter. This test method is not suitable for organic, saturated, or highly plastic soils that would deform or compress during the excavation of the test hole. Now, let's proceed with the materials. First up we have is the sand. The sand must be clean, dry, uniform in density and grading, uncemented, durable, and free-flowing. Balances or scales. Meeting specification D4753 with 5 grams readability or better to determine the mass of sand and excavated soils. Drying equipment or the oven. Miscellaneous equipment such as knives, small pick, chisel, small trowel, screwdriver, or spoons. Density plate with a central circular hole of diameter equal to the diameter of pouring cone, and shovel, hole digger, brush, moisture containers were also used.
In the first step, a scraper was used to clean and level a 450 mm or 0.45 meter square section of the site. Second, the metal tray central hole was placed on the prepared surface. Third, using this center hole as a guide, the soil was dug up to the necessary depth using a hole digger. The loose soil was then carefully gathered in the metal container and weighed. Fourth, the sand pouring cylinder was refilled with sand with full volume. It was weighed to determine the sand weight before the first pouring in the hole. Fifth, the metal tray with a central hole was removed and the sand pouring cylinder was placed centrally over the excavated hole. Sixth, the shutter was opened until the sand fills the excavated hole and the cone completely until there is no further movement of sand in the cylinder. Seventh, the shutter is closed and the cylinder is weighed so that the weight of sand filling the excavated hole alone can be found. Eighth, the moisture content of the excavated soil is determined by taking a sample of soil from it in a moisture content dish, weighing, drying in an oven at 1100 degrees Celsius, and reweighing. Ninth, these steps were repeated 3 times and the average values will be the field density value of the soil.
In this juncture, let us talk all about the interpretation of the data results. The sand cone method determines first the result of sand density in accordance with its process. Sand density is obtained by simply dividing the total mass of the sand by its total volume. We arrived at a value of 1,386.6 kg per cubic meter. Going to a deeper context, the value obtained is closer to the desirable sand density that is ranging between 1,442 kg per cubic meter to 2,100 kg per cubic meter. Before placing the excavated soil in the drying equipment, bulk density was determined first by the following its formula, which is the weight of soil divided by its total volume. Add the result from the 3 trials and get its average. 1,400.332 kg per cubic meter is the average bulk density computed. As the moisture of the soil vanishes after it was put in the oven for hours, the water content can be determined by dividing the difference of the mass of soil sample and mass of dry soil by the mass of dry soil, which arrived to an average value of 0.22966 or closely 22.97%. Lastly, the average density computed is 1,142.464 kg per cubic meter. That is based on the formula, which is the quotient of bulk density and the sum of water content and value 1. Overall, the desired goals were achieved and the values of densities were determined by the help of the sand cone method in accordance with the ASTM-D 155600.
The experiment that was conducted lets us determine the field density of sand and soil using the sand cone replacement method. ASTM-D 1556-00 was the test method followed in identifying the density of the said materials. This experiment provided sufficient data on how to compute the water content, sand, bulk, and dry densities. The methodology in conducting the experiment was repeated 3 times and the average values were used as the field density value of the soil. Based on the data and results, the sand density, which is 1,386.6 kg per cubic meter, is closer to the desirable sand density that is ranging between 1,442 to 2,100 kg per cubic meter. The bulk density was also calculated and has a value of 1,400.332 kg per cubic meter. The water content and dry density were also determined, having values of 0.22966 or 22.97% and 1,142.464 kg per cubic meter, respectively. Therefore, the experiment's objectives, which are to determine the density of compacted soils and to figure out the in-place density of natural soil deposits, aggregates, soil mixtures, or other similar materials, were met.